Hi everyone, welcome to Java Techie. Transactions are the backbone of any enterprise application. Whether you are processing the payment, updating the inventory, or managing user details, ensuring that everything happens consistently is always critical. In real world application, it's common to execute multiple database operations in a single method or in a single use case. But what happens when something goes wrong? How do you ensure that one failure does not break the entire system? That's where transaction management comes into the picture. So, in this tutorial, we'll dive deep into Spring Transaction Management, exploring how it works and why it's essential. Plus, we'll also cover different isolation and propagation level with hands-on example. Okay? Alright. So, without any further delay, let's get started. So before we directly jump into the code, let's first go through the use case to understand what is transaction and why do we need it in real time application. Okay, then we'll implement the transaction step by step. So first let's begin with a real time use case. So imagine you are working in a e-commerce project where you have the inventory service and it contains a product table with ID and what is the name of the product and what is the price of each product and then what is the available stock of that particular product in inventory. Fine. Now let's think user want to place a order. When user want to place a order, let's say user want to place laptop whose product id is 1 and you want to purchase 2 laptop. Now at first step what you will do, you will first save the order db. Let's say order id is 101, product id you want to purchase laptop whose id is 1 and quantity is 2. Then what is the amount? Amount is nothing, each product is 25k, so 2 product means 50k. So at first step, this is the first step. You save the order request to the order table. Then in second step, what you want to do? You also need to update the stock in inventory. Initially it was 10. User purchased 2 product. Then the stock value will be 8. Okay. That is what also you need to update. So once you are done with that update, then you need to also update the payment database. Let's say this is the payment db, this is the third step. So here to place an order we are performing 3 db operation. First one, persist it to the order db. Second one, update the stock in inventory system. Third one, save the payment information. Now let's say we have received another request of purchasing the laptop again and user want to purchase 5 laptop. Okay, so first step what we will do, we'll update the order db. Let's say order id is 102, product id user want to purchase 1, how many order you want to purchase, quantity is 5. Then what will be the price? Each product price is 25k. Based on that the price will be 1.25 lakh. So we save the record, right? Now what next? We are going to update the inventory system. It is 8 currently. We want to update it to the 3 because user already purchased 5 record. But imagine while updating in the inventory system there is a failure. It could be a network glitch or it could be some db connection issue in the inventory server. So there is some issue. We cannot update the stock price in inventory now. Then next step also we cannot perform, right? But if you observe, we already saved this record to our order db. However, we are unable to update the stock value which supposed to update as a 3. Because of the failure in the inventory service we cannot update it. Okay, but still we have this unused data in our database. Now what is the problem here? Let's say user want to search in the catalog service. you want to search the product, that is laptop. Okay, what is the count it will show to the user? 8, because it is available 8 product in the inventory, because the value is not update. It means the data in the order db and inventory service is not consistent. Okay, so there is a data inconsistency issue in my order db and inventory service, so which can break my system. So in such scenario, what I want, I don't want to keep the unused data. Rather, what I want to do, if anything going wrong as part of my flow, I want to completely roll back all the changes. Even I don't need this record in my DB. If there is a failure going on in my single flow, then I want to roll back everything. I want to revert everything from my all the dependent database. Otherwise, if all going good, then just commit that changes. That is what all about transaction. Okay, this is the simple principle of transaction. If anything going wrong in a flow, just roll back everything. If all good, then just commit them to the database. Fine. So I hope you got some concrete picture about what is transaction and why we need transaction in our application. So we understand the problem, that if while placing the order, if there is a failure on any flow, then the data will be inconsistent in my application. To overcome that, we can go for transaction, so that if there is any failure, then roll back. If failure, okay, otherwise commit if everything succeeded. Those things will be handled by transaction. Okay, so don't worry, we'll discuss the same use case. We'll create the order db and inventory db, then we'll try to replicate the same use case what we have discussed in this flow, to understand the need of transaction in real time. Okay, so let's go to the IntelliJ IDEA and let's create the project. So to save our time, already I created the template of spring transaction example. I have not write any use case or implementation. I have just created the template. Let me walk you through the code. So far what I have done here, first go to the pom.xml. We are using latest version 3.4.0 and JDK version 21. Then we added the Spring Boot Starter Data JPA, Web Dependency, MySQL Connector, Lombok, and also I added the Open API to use the Swagger. Okay. Apart from that, I also created the entity class, what we discuss in our flow, order with the ID, product ID, quantity and total price, product which is nothing, your inventory product details. We have ID, name, price and stock quantity. Fine. Now I have created corresponding repository for order for inventory. Then I have created a handler class called order handler, where we are just using the save order object. Okay, so I am directly using order repository dot save and pass the order object. Similarly, in inventory, I have the fetch the product from the inventory and then save the product. Okay, these are the simple logic I have written in handler class. Then we'll write the actual logic in our order processing service. So in order processing service, I injected both the handler class. Then we'll write our logic to place an order. Okay, so public so this is the operation we are going to perform here. Okay, so if you understand the flow, we discuss the same use case, order db and inventory db, and we are performing 2 db operation, 1 and 2. So let's do the same here. Go to the IntelliJ. Now let me note down the step what we are going to do. So I am trying to demonstrate this without transaction and with transaction with a real time use case. so that upcoming video when I will explain the propagation and isolation, we can come up with different real-time use case rather than just print the statement. Okay, so that is the reason I consider this particular use case. So first let me note down the steps we are going to perform. First we will get the product from the inventory. Once you get the product from inventory, then next you can validate stock availability. It means, let's say in inventory I have 5 product, let's say I have 5 laptop. User cannot send quantity as a 6 while he place an order. Okay, so the quantity from the order request should be less than the stock availability available in my inventory. Next you can update the total price. Let's say laptop price is 25,000, that is what we have discussed here, right? Let's say laptop price is 25,000. If user purchased 2 laptop, then it should be 50k. So this amount will update here. Update total price in order request or order entity. Fine. Once you are done with that, save the order. Then the last step, update stock in inventory. Fine. These are the steps we are going to perform. So let's go step by step. First, get the product from the inventory. So I will use inventory handler dot get product, give the product ID. So you will get it from the order request product ID. What it will give you? It will give you the product object, product from the inventory. The first step is done. Now what is the second step? Validate the stock availability. Now we need to check if the quantity given by the order request, if it is greater than the stock available in inventory product dot get stock quantity, then simply throw some exception. I'm just throwing runtime here. Fine. We validate the stock availability. Next, just update the total price. So you can do order dot set total price. How can you evaluate the total price? The number of order or the order quantity into price from the product. So you can do something like this, order dot get quantity into what is the price of each product, you will get it from the inventory. Okay, this is how you can update the total price of your complete order. Now just save the order. So you can use order handler dot save order. Just define the local variable. I will return the same order object. Okay. Now once you update the order, next you can update the inventory, stock in inventory. How you can update the stock? Nothing. What is the stock available earlier minus the quantity user purchased. Okay. So just do available stock. You can, how you will figure it out? First get the total stock available in the inventory handler, or you can directly get it from the product, right? Product dot get stock quantity, then subtract how much user purchased. Okay, so you can get it from order dot get quantity. Let's say earlier it was 10, now user purchased 2 order, then it should be 8, like that. Fine. Then just update it to the product dot set stock quantity, which is nothing, the available stock. Then just update the inventory. Call the inventory handler dot update, pass the new product. Okay. We define all the required step. Now for better coding practice, what we can do, let's move this logic to a private method. So extract them to a method. I'll just name the method update inventory stock. Then here also I'll keep it private method. So this looks good now, right? So we have defined all the steps. Now just access this particular method from controller so that we can test it. Go to the controller class. Again there is no logic. I have just defined the empty endpoint. So what we can do, we can simply call here new response entity, then just we can use dot ok and just call the method. So we can use order processing service dot place an order, pass the order request. All looks good now. Now let's run our application. This we are testing without transaction. We'll see the happy scenario, then we'll see the problem, then we'll understand how transaction helps to overcome that problem. Fine, that is the simple way we can validate now. All good. Now let me see what I have defined in my properties file. The port will run on 9191. Go to the main class, just run the application. So you can see here application started on port 9191 and also it created the table orders and product. Now let's validate the same. Just refresh the schema. You can see the table here, right? So let's check the record in these two tables. So there is no record in the product, even there is no record in the order table. So we want to add few record in the product table to execute our place an order, because at the first step we are getting the product from the inventory, right? So let me add few record. Now if you check the product, you have two product ID 1 and 2, name laptop, smartphone, price 25,000, 5,000, stock quantity, availability. See these two numbers. There are 10 laptop available, not laptop, yeah, there are 10 laptop available in the inventory, 12 smartphone is available in the inventory. That's the simple thing. Okay, now what I'll do, I will just open the Swagger. Now I'll just place an order. Let's say order ID is 101, product ID, what you want to purchase. Let's say I want to purchase this laptop. Okay, just pass the order ID, which is 1, not order ID, product ID. Okay, now what is the number of laptop you want to purchase? Let's say I want to purchase 2 laptop. What is the total price? It will be generated in my code. Just remove it. Now if I'll send the request to execute that endpoint, let's see the result. We got the result, product ID 101, order ID 101, product ID is 1, quantity 2. What is the total price? Can you see the price here? 50,000, because each product is 25,000. So we are purchasing 2 quantity, so it will be multiplied. Now let's validate the same in our DB. So these are the two product constant. First let me show you the order, then we'll come back to the product again. So this is the order entity, right? Now initially the stock availability in product for laptop was 10. Since we purchased 2, it was changed to 8. Now if someone will check in the catalog service, hey, I want to see the number of available laptop whose price is 25,000, it will display 8 in the UI. That is fine. We just discussed the happy scenario. Now let's try to break the flow. So just go to the inventory handler, what I want to do, let's say while update the product details, I'll forcefully throw some error. Okay, assume you will get some db crash error or some error in real time, but I cannot do that. So for that reason I am just forcefully throwing some exception. Okay, let's say I just want to check if product dot get some field, guys. Okay, price greater than 25,000, let's say, then I want to throw some exception. I'll give the meaningful message. Okay, let's say db crashed or something like that. Just a note. Fine. So here we are trying to replicate the same use case what we discussed. So when user will purchase the order or place an order, the request will save in the order table, but assume you are getting some error in inventory system. So that is the reason in inventory handler I forcefully throw some error to simulate the transaction behavior. Okay, better let's change it to 5,000 to throw the error. If you will keep 25,000, then definitely there will be no error, because if you will purchase laptop, the price will be 25,000. Okay, so change it to 5,000, that will throw the error. Just restart the app quickly. So application started. Now just validate the DV once. So we have laptop of 8 and other one is 12. Then if you check the order, we must have a single order. Yes, we have the last order which we inserted. Now let's do one thing. Just go to our Swagger and I'll insert another order of laptop only. Let's keep the product ID as 1. I want to purchase the 5 laptop now. Okay, so for your information, let me keep a note of it. Initially it was 10. Now at first time I purchased 2. Second time now I am trying to purchase 5. Okay, now let's do one thing. Let's trigger the request. Now what will happen, as per the flow we understand, the record will be inserted to the order DB. Then we'll see whether record is getting update to the inventory table or not, inventory product table or not. Now if you'll check, there is some exception. What is that exception? Let's see. Assume DB crashed, because while updating in the inventory we forcefully throw the error. That is nothing, DB crashed, the same error. Now let's validate in our DB. First let's check the order table. Great, we got the order request entry here. 102, product ID 1, which is nothing the laptop, quantity is 5. So 125 total price. Okay, now if we'll check the product, see the magic here. In inventory still it is showing 8, because while purchasing this order of 5 we got the error. Because of that error or exception, the inventory is not up to date. It means my data is not consistency across my application. Now what problem it will create in future? Now when user will come and check for this particular laptop of product ID 1, it will show the number as 8. However, in reality the order is dispatched out of 8. Now the total available product is 3, but still it will show to 8. Still it will show 8 to user, which will cause the overselling issue, and customer can be angry on your product or angry on your system. He might not be happy on your application, saying that okay, it is showing me 8 product available, but when I am purchasing that it is crying, saying that hey, I can't give you the product what you are requesting to me because I don't have available. Then why don't you update in your catalog service? Why don't you update your stock quantity in inventory? That is what the problem this can raise in future. Okay, so it must need to update. If you place the order, make sure you need to update the inventory. If there is some error while updating the inventory, then you must need to revert this entry from your order table as well, saying that at this moment we cannot consider your request, please try after later, or something. You can give the valid fault message to the end user rather than keeping this unused record. Okay, now how we can avoid this? So to overcome this kind of data inconsistency issue, Spring Framework provided a concept of transaction by just giving a annotation @transactional. Okay, so you need to play with this annotation to avoid data inconsistency issue in your application. Now let me show you how you can play with transaction. So till this point we understand what is transaction and why transaction. How to use it I will explain now. Okay, just go to your service. Now this is the method place an order who is doing multiple DB operation. When I am saying multiple DB operation, transaction will always applicable for insert and update and delete, not for the fetch. Okay, so in place an order, what we are doing? We are updating, we are persisting the order request to order entity, and also we are updating the stock in inventory. These are the two save and update operation we are doing in a single flow. Now what I want, if anything going wrong while updating the inventory, then also revert the changes from order table. Don't keep unused or stale data in my application, so that in future I will get the issue. Okay, to make the system stable, better revert at the moment when you get the failure. Okay, that is what the simple principle of transaction. Now how you can use the transaction now? Simple, just use the annotation transactional. There are two transactional annotation you can see, one from Jakarta, one from org.springframework.transaction.annotation. Just use the second one. Okay, then inside this transactional you have so many attributes. Read only, by default it is false. You can see here read only equal to false, which is the default. It means this particular method where I am implementing the transactional is not only doing read operation, rather what it is doing, it is doing the save and update operation. Okay, so you need to keep the read only false. Now if I will keep the read only true, this method will give me the exception. When you are defining read only true, transaction expecting, hey, you must need to define the fetch or get method or select method. Okay, so by default it is false. Then there is a property called propagation. Can you see here propagation? Let me define the propagation first. Currently I will use the default one, which is propagation required. Okay, so what this propagation does at high level, if you will understand, propagation deal with how multiple transactions can communicate with each other. Okay, you no need to go deep at this moment. As I mentioned from the beginning, I will cover each and every propagation and isolation level in details with proof in my upcoming video. Okay, so keep it propagation required. Then you can define isolation. Isolation default is default, but no one is using that. It is specific to the DB what you are using. I'll just use read committed. Again, what do you mean by isolation? Isolation controls how one transaction see the changes made by another transaction. Okay, whether you want to read the committed data, or you want to read the uncommitted data, or you want to do the repeatable read or serializable read, there are different type of isolation. Okay, so let's go with the default attribute or default value of each and every attribute at this moment. Okay, so you can remove this. By default it is false, so you no need to define it. Now let's see the magic. We'll run the code and we'll see the magic now. Okay, now let me restart the application. So it started. Now what I'll do, first I'll go to the DB. I will first remove this manually. Okay, this is completely useless for me or for my application. So I'll just delete the record whose ID is 102. Fine. Now if we'll check the order table, you have a single record. Now if you'll check the product table, you have a single record. I mean two record, laptop and smartphone, all are unique, the value is updated. Now what we'll do, let's test our flow. Now we are testing with transaction. Okay, so go to the Swagger, let's say ID is 2. Now I want to purchase the smartphone. Okay, 2 quantity, let's say what is the available quantity I have, 12, right? I want to purchase 7. Now just click on execute. So if you observe, there is a insert operation, there is a update operation without any failure, because if you see the request, product ID 2, the quantity is 7. This is the 2 and 7, right? So if you check in the DB, this 2, which is nothing the smartphone, that price is 5,000. Each individual product price is 5,000, and earlier it was 12, correct? It was 12, right? So when we purchased, how much? 7, correct? It is 5 now. That is correct. This is happy scenario. We didn't get any error, because what we are forcefully throwing the error here, if you check here in the inventory, we are checking the, where it went, in inventory handler, right? We are checking the price is 5,000, but we are giving the price as a 5,000 because each mobile or smartphone price is 5,000, so you won't get any error here. You can reduce the number to validate or test your smartphone use case, but let's go with the laptop use case, because that price is 25,000, which is more than 5,000, right? So go here and try 103 product ID. Again I will come to the laptop 1 and I want to purchase 5 quantity. Okay, now click on execute, come here, go to the console. We got the error. What is that error? DB crashed. Now go to the DB and just validate. Let's say I want to check the order DB first, order table. Can you see the record? 103 and the product ID 1, quantity is 5 and price is 1,25,000. No record is inserted, right? Now if you'll see the product table, which is nothing my inventory table, does it update the count? Let's see. No, still it is 8. In this case, since we found there is a failure, we are performing 2 DB operation. One, we are persisting the record to order table, and second one, we are updating the inventory. Since we found the problem in one flow, we revert everything. Even we don't keep that unused record in my order table as well. We have not inserted the unused record, because for that record, when we are trying to update the inventory system, we found the failure. So for that reason, to maintain consistency, we removed all the record, all the dependent record from different database. Okay, now in this case, what happened, when a user will check the product in catalog service, let's say you want to check for laptop whose price is 25,000, it will give the correct count to him. Now he will get 8, because that is what available in the stock, that is what available in my inventory system, correct? Now my data is consistency across my application. I will not get any overselling issue. Okay, so that is the main purpose of using transaction, to avoid data inconsistency and to maintain data integrity in your application. Okay, so this is what all about what is transaction, why transaction, and how to use transaction in Spring framework. So this is just basic use of transaction we understand here. In my upcoming tutorial, I will cover each isolation and propagation label. So if you see here, there are 7 or 8 propagation label. Can you see here? Required, supports, mandatory, required new, not supported, neighbor, nested. Okay. Since they have defined different type of propagation label, each and every label must have their some use case, right? When I will go for required, when I will go for required new, when I will go for nested, or when I will go for mandatory. You should know that rather than just knowing the theory about what is propagation and what is the default one and how can I use it. Similarly, if you will check the isolation, if you will go back and if you will check the isolation, you will find 1 2 3 4 5. This you can ignore. You can find 4 useful isolation label: read uncommitted, which is nothing your dirty read committed, but it will not stop the repeatable read, which will not, I mean, what I can say, which will not handle the phantom read. Okay, then last one is the serializable read. Okay, so there are again 4 type of isolation label we have. So I hope this particular use case plays an order by defining transactional, propagation and isolation. We also see the problem with the transaction, then how we solve it using the transaction, right? Let's begin by understanding what propagation is all about. Once we have got that, next we'll discuss different type of propagation with example. Okay, so in transaction context, propagation defines how transactions are managed when a method is invoked with another transaction. For example, let me simplify this. Let's say you have two method m1 and m2. Okay, so this is m1 and this is m2 method, and both the method implemented transaction. Now here, since you have two different method and both are implemented transaction, let's assume you are invoking m2 from m1. Now how you want your method to be executed? For example, let's say m2 transaction is failed. Then how you want your m1 transaction to continue? Whether you want to persist the record or you want to revert the record. Okay, similarly, let's assume m1 transaction failed. Then you want to persist the record in m2 transaction or you want to roll back everything. So there are different type of permutation and combination you can play using these propagation properties. Now if you go to the source code and check different type of propagation properties, you will get some clear picture about it. Let's go to our code. So if you will go inside this propagation enum, then you can see here there are different propagation type: required, supports, mandatory, required new, not supported, never, nested. There are total 7 propagation type. So we'll discuss each and every propagation type with example, not just by theory. Okay. Even though in real time we are not using all, few of them we are using, but still it's good to know all the propagation types, so that in future if you will get such kind of scenario, you will be in a state to decide, okay, this is the use case, I need to go for this not supported or mandatory or any of the propagation type. Okay, so let's begin with the first one, that is required. Let's go to our order processing service. Then first let me keep a note of what exactly this propagation required means. If I'll define propagation required, then how my transaction will behave. Okay, so you no need to remember the theory, let's understand it. Required means join an existing transaction or create a new one if not exist. Okay, so the statement is very simple. Since you have defined propagation required, first it will search for is there any active transaction. If yes, I am good, I will reuse that. If not, then I will create a new transaction. Okay, so to demonstrate different type of propagation, what we can do, if you understand here, propagation means when you will call, there are two transactions M1 and M2. If you will call one transaction inside another transaction, then only you can play with the propagation behavior, right? So let's do one thing. This save order will use the transaction here. Better I will copy here. Okay, I will copy the same statement. Just remove the isolation. We are not going to discuss about isolation in this video. That I will update in my next video. So let's copy this, paste it. Similarly, just go to the update inventory stock, then update product details. Now, if you see the code, order processing service, we have a transaction. Let's say this is the transaction 1. Then from inside place an order method, we are doing another, we are just invoking another two transactions, save order and update inventory stock. Now since these are two inner transaction and this is my outer transaction, let's see how it behave. So when, let's say there is some failure, whether it is roll back everything or it will keep the stale data or it will do the partial commit, let's validate that. Already we validate because the example what we tested in our last video, that by default consider as a required, right? But let's prove that when you are using propagation.required, it will create a single transaction and reuse it. We are sure about the behavior, how it will behave, but let's see whether really it create a single transaction or not. Similar way, we can go with different propagation. We'll check the behavior and we'll validate the transaction statement. Fine. Now what I can do, let's run the application. So it started on port 9191. Now let's see what is the happy scenario we have and what is the failure scenario we have. Okay, so we forcefully throw some error while updating the product details in inventory, saying that if product dot get price greater than 5000. Now if we'll go and check in the DV, I have added couple of more product. Okay, so if you are purchasing some product whose price is greater than 5000, then my inventory update will fail. Okay, so if that is the case, you need to purchase the product ID 1, which is laptop, or 4, which is TV. Okay, in these two case only we can find the failure scenario. If you will try for 2 and 3, it is the happy scenario. Fine, just go to the Swagger documentation. Now what you can do here, let's try it out. Let's set order ID equal to 1 not 3, product ID want to purchase 3, quantity I want to purchase 2, total price it will be auto generate in the code, just remove it. This is what we are trying the happy scenario. Okay, now I will execute it. We got the result. The price is, total price is 3000 because individual product price is 1500. Now if we'll check in the DV, the total count was 50. Now I'll just execute the select statement. We purchased 2, the inventory is updated correctly. Now if we'll check the order, the record is inserted. Correct? Now let's go with the failure scenario. We'll see if anything is getting failed, whether everything is rolled back or some partial commit will be happened in my transaction. So let's check that. Just change the payload, that's it. ID will be 104, product ID 1, quantity let it be 1. Now execute. We got the error. Now let's validate in our DV. Just select star from order, execute this. Did you find the record 104? No. Now similarly, let's check the product. Did it update the count, laptop count? No, it is 8 only. This is expected behavior in transaction propagation label required, because that is the default one which we already tried. But can you prove me that it is only create the one transaction? In update product details we are creating a transaction, in save order we are creating a transaction, and we have also one main transaction while placing an order. Will it create three different transactions, or it will reuse the transaction if anything is active? Can we validate that? Yes, that is what you can do. Let me add a debug properties to just visualize the transaction log in application.properties file. You must need to add this because by default Spring Data JPA will use the JPA transaction manager. So you make sure to enable the debug for that. Then you can find all the transaction specific log statement. Let's run it and we'll see whether it is creating a single transaction or not. Just restart the app. So it started. Let me clear the console. Now let's go with the happy scenario first. So let it be the ID is 4. Now I cleared everything. Just send the request. You can see there are so many log statement, right? So let's read them one by one. This is the only way I can prove that okay, required is not creating the duplicate transaction, rather than it is reusing the active transaction. So just read it carefully. Creating a new transaction with name, place an order. Okay, that is my main transaction. Can you see here? When it created, place an order, that is our first transactional we have defined. Now to save the order and to update the inventory, does it create a new transaction? Let's validate that. Now participating in existing transaction, can you see here? Committing a transaction on entity manager. Did you find any another create statement here anywhere in the log? No, right? It means if you are defining required, it will reuse the transaction if anything exists, like this participating in the existing transaction. If not, it will create a new transaction. Okay, that is clear. So we are not relying on the theory, rather we prove it with our code. That's good. So you understand when to use transaction propagation label required, when you want everything fail or everything succeeded. If you have a use case, if there is any failure, you don't want to keep the unused data, rather you want to revert everything, then go for propagation required. Okay, now let's move to the next propagation, that is required new. When can I go for required new? First let me give you the definition of required new, then we will understand in what exact use case we can go for this propagation label. Required new, what it will do, if you will define propagation required new, then it will always create a new transaction, suspending if any existing transaction. Okay, so required new means this name itself giving the clue what it will does. I always need to create a new transaction irrespective of whether there is something running or not. If something running I found, I will suspend that till my execution completed. Okay, so when you will go for the required new, that is what the key things you need to understand. So let's say place an order. Inside that we are just persisting the order to the DB and we are updating the inventory service. And we understand both these two operation is running inside a single transaction. Correct? But we want irrespective of these two operation whether it is succeeded or failed, we want to keep an audit log so that we can track the failed order and we can proactively remind user about them, which will help my product or my system or my application to improve customer engagement. Okay, irrespective of save order or update inventory in stock, anything is going fail, that is fine, that is the valid use case, but I want to keep a audit log of those failed record so that I can reprocess them. Okay, how will you handle that situation? If let's say anything I will write, let's say I will write a method, uh, audit order details, and you have some, you pass the order. Okay, now let's say this is the method I have. Now since I am writing this method inside the transaction where I have defined required, it means if save order failed or update inventory stock failed, this will also reverted, right? But I don't want to do that. Irrespective of any success or failure, I want to keep a log of that. Then, in that case, what you can do, you can define this audit order details method saying that hey, I need required new propagation. Okay, just change it. Here you are saying for this audit order details, I am I need a new transaction, required a new transaction. Even though save order update inventory is running on a main transaction, I don't want them. I don't want to use that transaction. Rather, I want to create a new transaction. So I need a or I required a new transaction. So in such case, when irrespective of failure or succeed on the existing transaction, you must want to execute your thing, then you can go for required new. Hope this definition is clear for you. Now let's implement the same use case. So let me quickly create one audit log entity. Just go to the entity section. Okay, this is the audit log entity. Then just quickly create the repository for audit log. Fine. Then I will just create a handler class for audit log. Nothing. I have just defined method log audit details, order, and what action, whether it is succeeded or failed, and current timestamp. Then I am just persisting it to the DB. Next, we'll just define the transaction. Make sure it should import from the correct statement. It should be from the transaction spring framework. Okay. Now in this transactional, what propagation I should mention? I should mention propagation required, right? Is this correct? No. If I'll define propagation required, then it will use the existing transaction what I am using in place and order. If anything goes wrong, it won't persist anything to this audit log. But that is what I don't want. I want irrespective of succeed or failed, I want this must need to be execute. So I can go for required new. Fine. Now let me call this log audit details in this order processing service. First let me inject that handler class private final. Now just call this audit log handler here. Audit log handler dot log audit details and pass the order object. What it need? Order and action, right? So we don't know whether it is succeed or failed. For that, what we can do, we can keep them in a try catch. If catch, then the action will be fail. If it will execute in the try, the action will be succeeded. So what I will do, I will just do one thing, then catch, saying that order placement. Now copy this If there is no error, just keep this. Fine. Now keep this outside. I want, irrespective of succeed or failure, this audit log handler must need to audit the order details log so that I can grow my business. If there is a failure, I can keep remind to the user saying that, hey, you tried for this order, but the placement was failed. Would you like to retry it? Now just remove this. We don't need. So let's run it. Then we'll validate. Let's clear the console first. Then let's try the happy scenario. Then we'll try the failure scenario. Just go here, and what is the last order we have in our DV? 104, right? So change the ID to 105, product ID 3 and quantity 2. That is the happy scenario, right? 3 means what is the product? If you'll see here, the product 3 is watch, I guess. Yeah, watch. Price is 1500. We won't get any error. Current count is 46. Let's run it and we'll validate. Just execute it. This is the result. Now if you'll check in your DV, count is updated to 44 and record inserted. But let's validate the statement we have defined in required new. Always create a new transaction, suspending if any exists transaction. Okay, so just go to the console output and we'll see the statement. Let me zoom this. Just observe here. First, it create a new transaction for place an order. That is my main transaction because we have defined propagation required. Now it will save the order. It will use the existing transaction. Then it will update inventory. It will use the existing transaction. Now if you see here, suspending current transaction, creating a new transaction with name audit log handler log audit details, because this is a method where you have defined I need propagation required new. So in that place it is creating a new transaction by suspending existing transaction. Once this log audit details logic will be executed, then it will release the transaction and your old transaction will be executed. Can you see here? You will find that statement as well. Suspending current transaction, open new, exposing JPA transaction, not this one. Transaction commit JPA transaction on entity manager, initiating transaction. See here, resuming suspended transaction after completion of inner transaction. Inner transaction is nothing, your log audit details. After completion of that, it resume the main transaction, which is nothing, place an order. Okay. Now let's see whether it added the entry to the audit log table or not. Refresh. We have the table. Great. We have the record order placement succeeded. Fine. Now make sure you need to align to this definition what we discussed in the beginning and whether we are able to get the same result in console output or not. Okay, that will give you the concrete picture about the propagation, whether really it is working or it's just a theory. That's fine. I don't want to go in deeper to the log statement. Just clear everything. Now let's see the failure scenario. Now what we are expecting, since we have defined the required new and we understand from the console log, it is creating a new transaction. So if there is any failure while updating the inventory or persisting the order, irrespective of that result, my transaction should execute. It should keep the audit log for me. Now let's try the failed scenario, then we'll validate that. 106, product ID 1. If I'll purchase laptop, I should get the error. Quantity, let it be 1. Anyway, the record will not going to persist. Click on execute. We got the error. First validate in the DV. Great. We got the order placement failed audit log. But if you'll check in the order, the count is same. There is no change. Okay. Which one is our, not this one, this one our order, right? The new record is not inserted. Now if you'll check the product, the count is still 8. There is no update. So we got the audit log result because we have defined required new. So it will must be execute. Now if you'll see the statement, log statement here, it create a new transaction on place and order because you have defined propagation required. Then it will use the existing transaction, suspending current transaction and create a new transaction for audit log. Okay. Then resuming the suspended transaction. Okay. Resuming suspended transaction after completion of inner transaction. Then you will find something rollback. Yeah. Transaction silently rollback because it has been marked as rollback only. Okay, because we got the error. Fine, let's clear everything. We are good here. So we understand required and required new. These are the two propagation widely used in industry, and there are few more also people using in industry. Let's understand everything. Okay, just go to the propagation. We are done with required and required new. Now let's move to the next one, that is mandatory. Okay, so first let's understand, when I will define propagation as a mandatory, what will be the behavior of my transaction. Okay, so when you will define mandatory, what it does, it require an existing transaction. If nothing found, it will throw exception. Okay, so it's simple, right? So what it says, if the method is called within an existing transaction, it will participate in that active transaction. If the method is called outside of an active transaction, it will simply throw an exception saying that illegal transaction state exception. Okay, now let's think about the use case. Here you have persist the order and you have update the inventory. Now also, what I want to implement here, I want to validate the payment. Okay, I want to validate the payment. If the payment fail, we still want to track the payment failure in a separate log, but I don't want to roll back the entire order creation and inventory update mechanism. Okay, so what I want, let the flow execute as it is. Additionally, I want to validate just a dummy piece of code. I'm just giving you the use case. So let the place and order flow execute as it is. Additionally, I just want to validate payment. Let it be. I just want to validate the payment, and I want to use the existing transaction. I don't want to create any transaction for it. Rather, this validate payment, I want to use the existing transaction which is running by or initiated by place and order. This is what my use case to demonstrate propagation label mandatory. Mandatory means I need my method to execute within any existing active transaction. If I won't find anything, then simply I will cry. Now let's try to demonstrate this code. So let's create another validator or handler class saying that payment validator handler. So here I am not doing anything, guys. Validate payment. Forcefully I am trying to fail the payment status, and I'm just keep a audit log. That's it what I'm doing. Okay, I'm using the same audit log entity again, rather create another entity saying payment audit log. Let's use the same. We just want to understand the use case and behavior of that propagation type. Okay, so this is simple. Now what I can do, I will just inject this in my order processing service. just use this handler now. Payment validation validator handler dot validate payment, give the order. Good, right? Just go to the validate payment. We'll do one trick part here. What we'll do, before I save it, or okay, before I save it, I'll just throw some exception. Okay, if let's say order dot get total price, let's say it is greater than 100, let it be, okay, or 1000, always we want to fail and we want to validate it, that's it, 1000. Then I will throw new runtime exception with some message. Okay, also this validate payment, I want to run an existing transaction, so I will just define transactional propagation. Propagation you can define mandatory. Okay, now what does it mean? This particular method, even though this will fail here, if I'll call them from the order processing service, it will not harm to this particular guy place an order. Okay, even though from place an order we call this validate payment with transaction propagation mandatory, what it will say, hey, you just execute me as part of your code. If there is some failure on my code, I won't impact to you, you just take me with you. That's what he is only requesting if you will define the propagation mandatory. Okay, if any failure in the payment handler class, still your order and update will be save as it is, the flow will not break, but this guy only requesting for to use your transaction. That is what the main goal if you are using propagation mandatory. Let's validate it. Okay, now let's restart the app. Let me cross validate, scroll down. I guess we don't need to throw the error because already forcefully we are trying to keep the payment successful status to false to just simulate the failure scenario. Okay, because we just want to keep a log, that's it. So just remove this. Now all good, just restart the app, then just clear this, go to the swagger. What is the last order we have? 105, right? So just change it to 106. 3 quantity, let it be 2. Just execute it. There is a bad request. Okay, so this is wrong. Now execute. Record got inserted. This is happy scenario we have tried. Okay, now if you see here, let's see the statement, this audit log. We just want to validate, since we have defined mandatory, it should not create a new transaction, rather it will request place an order transaction to continue. So if you see here, just check the statement, create new transaction. This is the single statement for place an order, propagation required. Now let's validate, it's suspending the current transaction, create new for audit log, because that is what we have defined required new. That makes sense. Now scroll down, resuming suspended transaction and continue the other one. Yeah, there is no other transaction, rather it participate in existing transaction. Okay, this is the statement, right? Audit log update, it is using the existing transaction, just clear it. Now if you go and check in your DV, since there is fail in payment validator, it should not break your flow. We got the entry in order DV. We also value get update in the inventory. That's what the role of mandatory propagation. Now to validate that, if it won't find any existing active transaction, it should cry. What I can do, I'll just go to the order processing service. I'll just comment this, there is no active transaction now. Okay, and also I'll do one thing to keep the things clear. I'll just comment this for now, or let it be. Okay, I'll just comment it. Now what we can do? Now is there any active transaction when this method will execute? No. It should throw the error illegal state transaction or something like that. Okay, I didn't remember it, but let's debug it and we'll see the result. Just stop it and start in a debug mode. Just clear everything, send the request. Now let me evaluate this expression. If you see the result, what you are seeing here, method through org.spring-framework transaction illegal transaction state exception, no existing transaction found for transaction marked with propagation mandatory. So this sentence is clear, right? Mandatory always need an existing transaction. If not found, it will simply give you this message to you. It's clear, right? Cool. Now what I'll do, I'll just comment this. Just stop it. Now let's move to the next propagation. Let it uncomment. Now the next propagation we are going to discuss about the never. Okay. Now first let's understand what do we mean by never propagation. So let me keep a note first, then we'll understand. So if we'll define propagation never, it will ensure that the method will execute without transaction. He never need any transaction. If he found any, he will cry with the exception. Okay. So let me keep a note. The method will run without transaction, then throw an exception if found any. See, the name itself is clear to understand. Never means if you have a method who don't want to be part of the transaction, even though you will keep them in transaction, it should not break your existing flow. Rather, it will cry, hey, I don't want to be part of transaction, keep me separate. In that kind of scenario, you can go for never. So looks like never, mandatory, and other propagation type looks similar, but the purpose is different. Mandatory, he must need a active transaction. Never, he don't need any active transaction. Okay, just keep the thing simple with this kind of word so that it will be clear for you. Okay, now when you will go for never, that's very interesting. So let's consider a use case. While placing an order, we are updating our order DB and we are updating the inventory. Now what I also want to send order confirmation to the user. I want to send order confirmation either over email or using the mobile, I mean the message. Okay, so this I want to execute, but this I want to execute without any transaction. The reason, let's say I am executing it with transaction with the same flow. Now save order is failed or update inventory stock is failed. Then in real time what you do? We do implement the retries. I will do retries 3 times. Then 3 times this method will execute, which I don't want. Why should I send notification to the user when I'll retry? Hey, your order is failed. Hey, your order is failed. If I'll do the 5 time, why he will get the 5 time duplicate message that you are retrying, but end user is keep getting the same messages what you have configured. So to avoid that, what I want this to be completely out of transaction. In that case, you can go for propagation never. Okay, so let's do it right now. Let's try to understand it. So let's create another handler for send order confirmation. Now go to the handler, notification handler. Now here what transaction I want to use? I want to use the transaction propagation never. Okay, I don't want this method to be part of any transaction since I'm just sending notification. I have not written any notification logic, rather I just print the statement. Okay, you can add the logic, it's just a demo, so let it go with the flow. Now this is my send order confirmation method. Now what we'll do, we'll just inject this handler in our order processing service, then we'll see. Now just call the method. So I'll just call here notification handler dot send order confirmation notification, let it be. So I'll give the order. That's it. Okay. Now let me run in a debug mode. Just since you understand the theory, now if I'll call this method within an existing transaction, will it work or not? That is what first we are going to test. If it will not work, then we need to keep it outside, because that is what the transaction propagation label says. I never want to be part of any transaction. Let's run in a debug mode and we'll validate. It started. Go to the Swagger and just change the ID 107, send the request. Now if I'll evaluate this expression, what should I get? Let's see. Can you see the messages? Since we have defined this send order confirmation method as a propagation never, it is saying illegal transaction state exception with the messages existing transaction found for transaction marked with propagation never. So I will not execute with you since you cheated with me. Okay. So then in such kind of scenario, what you will do? You should not keep this. You can call this particular method outside the transaction, something like this. So you can do process order. This method does not have any transaction. You call the place an order who will execute with transaction, but this guy you can keep it here. Okay, now this is not part of the transaction, it should work. So let me comment this. Fine. Now let's move to the next one. The next propagation not supported. Okay, let's understand what this not supported propagation means. Just go to the order processing service, then let's do one thing, just keep a note of it. So when you will define propagation not supported, what it will does, it will simply execute the method without transaction, suspending if any active transaction found. Okay, so execute okay, makes sense. So this is simple, right? I don't want to execute in a transaction. If I found any, then I'll simply slap that transaction. That is what this not supported. I will not support any transaction, so don't come in my way. That is what means not supported. Now in what situation you should go for this not supported? So this type of propagation is useful when you want to perform an operation that does not require a transaction, like you just want to perform some read only operation. Okay, or you want to just perform logging or sending notification. For example, let's consider a use case here only. When you place an order, you save the order to DB, we update the inventory. Next to that, since you are my customer who is placing an order, what I will do, I will have some surprise for you. What is that? I will give some future product recommendation to you. Since you are purchasing watch, you might like the new accessories come from the watch category. So I will give some recommendation to you at the end. Okay, so this is what the business strategy, right? When you are searching something on Amazon, or any e-commerce platform, you are searching some dress material, let's say t-shirt, then it will suggest you so many t-shirts, and you purchase some brand, then it will suggest, let's say it identify that you are searching with the range 1000, then it will give you all the recommendation which comes under that range, okay, with different brand. So that is what the strategy, right? When user place an order, don't give him with the response, okay, your order is placed xyz. Give him something to watch and interest to purchase the things again. That is how I can grow my business, isn't it? So let's try implementing that things. Let's provide the recommendation, a product recommendation, which is kind of read operation. I will just fetch the product from the inventory by just applying some filter and all. Okay, so in that case I don't need any transaction. If any transaction comes in my way, I'll simply kill them or I will simply suspend them. In such kind of scenario, you can go for transaction propagation not supported. Okay, now let me create a product recommendation handler class. Go to handler package and then I'll just create this product recommendation handler class. So there is no complex logic. If you see the code, I'm just returning few hard coded product as a recommendation, and we have defined the propagation as not supported. So this customer id is useless for now. Let's remove it, we don't need it. Okay, so anything else not required, just update it. Next, just inject this in our service class, then we'll access it. Just quickly do that step. Now just call that recommendation handler dot get recommendation. So what we will observe here, in happy scenario this should execute, in failure scenario also this should execute, because not supported will say I will execute, I don't need any transaction, I will execute. If some transaction I will see, I will simply suspend that. That is what this guy is saying. Okay, so how we can validate that? By just seeing the log. So what we can do, all good, let's see. Yeah, all looks good. Just restart the app. So it started. Just clear the console. Now go to the Swagger and change the id to 8. Just execute. This is the happy scenario. The result is update. Now just check the console log. Can you see here? Recommendation fetched for customer, and if you see the complete transaction log, see here, before it execute recommendation fetched for customer, okay, it found there is a active transaction which is nothing, your place an order. So it suspend that current transaction. Then once it execute the what is that, the recommendation engine logic, then immediately it resume the transaction again. Okay, that is what not supported means, right? I will execute, but if I found anything, I will simply suspend it. Once I will complete, you can continue, I don't have any issue. That is what not supported. Now let's run in a failure scenario and we'll validate. So just go here and change the id to 109, product id 1, which is laptop. Just execute. There is a failure, but let's see whether we got the result or not. Can you see here? I don't care whether there is a transaction or not. I will execute my stop. If I found anything, I will simply kill that. Let's see whether that is happening or not. Yeah, suspending correct transaction. Then it execute the recommendation engine logic. Then it resume the suspend transaction. Let you work now. I don't have any issue. That is what the meaning of not supported. So we are good. Now let's move to the next propagation label, that is supports. Okay, now let me keep a note of it. If from the beginning I will give all the definition, it might be confusing. Since we are going one by one definition, then we are doing the POC to prove that concept. That in that way we can understand the complete context of each and every propagation. I hope we all are in the same pace. Okay, so now let's keep a note of supports. So when we'll define the propagation as a supports, what it does, it supports if there is any active transaction, if not, he will execute without transaction as well. Okay, what supports means, I will support transaction if you are giving me, well and good, I don't have any issue. If you are not giving it to me, then also I am fine, I can execute without transaction. So again I repeat, supports, not support, never, mandatory. This definition might be little bit similar, not exactly similar, but when you will try to understand the definition with the use case, you will get the clear picture. Okay, not supported, simply deny, I don't need any transaction, I will kill them. Once I will execute my things, then you can continue yours. Supports, what it is saying, I am fine with either or. Give me a transaction, I will execute with it. Don't give me, I am happy with that as well. Okay, so now think about the use case where you can go for supports propagation label. Now you can consider a simple example. While place an order, you might need the customer details, the customer delivery details, address details to dispatch the product. Okay, that is simple. The get call, that is fine. If you will keep them in a transaction, it will execute with that. If not, also there is no issue. Okay, or you can also consider the last use case what we have to understand, this get recommendation. Okay, but since we are trying to understand the new one, let's go with the new use case. So I'll not create any handler class now. To keep it simple, I'll just define a method public void get customer. Now I'll just, okay, let it be string, or I'll just print it, no complex logic, customer details fetched. Now I want to keep this transactional annotation with propagation. What is that? We want to keep the propagation as a supports. Okay, so I'm not doing any complex logic, rather I'm just printing the statement. So we already commented this. Good. I'll just call this method get customer details. Now what is our expectation here? This guy should execute with and without transaction. Okay, so let's run it and we'll validate. Again, this is the happy scenario, just change it to 110, execute. Why there is error? Okay, we tried with the failure scenario, right? Let's see. This guy executed, right? So that is what now we want to validate. Let's change it to execute. We got the result. So you can see here. Now if you see here the statement, it should participate in an existing transaction. Can you see here? Now if I will comment this piece of code, this main transaction, and if you will execute also, this will be work fine. So do you want to validate? Let's restart the app and go to the Swagger, change the ID, execute. We got the result. Now if we'll check the console output, customer details fetched. This worked without any transaction. After close the transaction, see here, we close the transaction, still it is working like a normal method. Fine. So we are clear about the supports. Now the last one we have that is nested. Nested, again, to use this nested, it depends your DV configuration. JPA directly don't support this nested. I'll show you the error what we are getting with the nested. First, let's understand what is this nested propagation type. Okay, so just go here and keep a note of it. So when we will define the propagation as a nested, what it will does, it will execute within a nested transaction. Then it will, what it will do, it will allowing nested transaction to roll back if there is any exception or error. Okay, without impacting, what is that, without impacting what you can say outer transaction. Let's break it down. To roll back, let it break from here. Okay, so nested means you can understand, right? It will execute within a nested transaction, so that if anything goes wrong in that nested transaction code, it should not roll back the outer transaction. For example, let's consider something from here. Okay, place an order. This is my outer transaction, right? Let me add a note. This is my outer transaction. So here what I'm doing, I'm just the main DV operation, save order and update inventory stock. Now this get customer details is also there. Let me comment it. Let's say I'll just use this payment validation handler, validate payment. I'll change it to nested. Okay, and I'll throw some exception here. So what is that? Okay, let me add this. Okay, keep it nested now. Now what do we mean by this nested? It means this is the nested means you can consider child transaction. Okay, now since this is the child transaction, if anything goes wrong on this validate payment, I don't want this order processing place an order to roll back. There will be any impact on save order or update inventory. I don't want that, but I want to run it in a nested transaction. Nested means nothing. This is the outer transaction, inside that another transaction. Okay, now if I'll call this method payment validator handler dot validate payment, if I'll debug this for you, let's stop it. Let's restart the app. It started. Just go to the Swagger and trigger the request, change the ID. You can go for happy scenario, that's fine. Anyway, we won't get any result. I'll tell you why. Now if I'll execute this, can you see the error method? ORG transaction, nested transaction not supported exception. JPA dialect does not support save points. Check your JPA provider's capability. Since we are using Spring Data JPA, I can't show you the use case what we discuss using this nested propagation, because JPA dialect is not supporting it. Okay, so you can try with the plain JDBC to understand this nested flow. But what we understand about the nested propagation, I want to execute some logic in nested transaction propagation, but if there is any failure on my nested code, I don't want it to block my outer transaction, or I don't want it to block my actual business flow. In that case, you can go for nested. Okay, this is clear for you, I believe. So we have covered all the different type of propagation, not only theory, we also understand different type of propagation with different valid use case, and we prove each and every propagation with concept log. Okay, hope that is clear for you. Not only theory, we did the post-mortem of each and every propagation type in action. Honestly, in real time, we do use required, new, and mandatory, and others I have not seen so far. But again, it depends on the use case, what type of use case you are implementing. Based on that, you need to choose the propagation type. I hope now you are in a state to select the propagation if you will find some. So first, let's understand what is isolation. In transaction, isolation controls the visibility of changes made by one transaction to other transaction. For example, there is two transaction T1 and T2. What T1 is doing, it should be updated to the T2. That is what the role of isolation, to make the data consistency between multiple transaction. Okay, let me keep a note of it. So we understand at high level what is isolation, right? So don't worry, we'll demonstrate each and isolation with valid example. Now first let's go and check what are the different type of isolation available in transaction. So you can validate here, just add isolation, then go to the isolation enum. If you see here, there are total 5 isolation label: default, read uncommitted, read committed, repeatable read, and serializable. So we'll do the postmortem of each and every isolation label here. Okay. So let's begin with the first one, that is default. So this default isolation label is specific to your database. So what database you are using and what is the default isolation label set to that database will be used if you will specify the isolation as a default. For example, let me go to my database. Now if I'll trigger the query here, so variable like, you can define transaction isolation. Okay. Now if we'll run it, okay, this is transaction. Can you see here what is the default isolation label configured in my database? That is repeatable read. Okay, so now if in my code, if I will use the isolation as a default, it will by default take as a repeatable read. It will by default set the isolation label to repeatable read, because that is what by default configure in my database. So you can override that, you can change it to read committed, read uncommitted, or serializable. That you can override using the query. We'll understand that in a moment. Okay, so if you are using default, you know what is the status, right? It will take any of the isolation label from down. That is what you will configure in your DV. So default you can ignore it for now. Once you will understand these four, then you can set default and you can override the value in DV so that it will take that specific isolation label. Fine. So let's go to the next isolation label, that is read uncommitted. So I will tell you the problem statement using each and every isolation label, then I will show you how you can solve it. That way you can understand the clear picture of when I should go for this type of isolation label. So let's begin with read uncommitted. Let's consider an use case, same inventory system. You have the product table with ID, name, price, and stock value. Now what isolation we are going to discuss, that is read uncommitted. Okay, we are going to discuss about read uncommitted isolation. What do you mean by read uncommitted? We just want to validate if there is a transaction 1 and there is a transaction 2, if anything going change here, whether it is reflecting to the transaction 2 or not, or what value it is reflecting to the transaction 2. That is how you can validate the different isolation label. Okay, just ignore it. We'll go with the valid use case. Now imagine there is a transaction 1 and at the same time there is another transaction that is called transaction 2. What transaction 1 is doing, he is trying to update the stock value. Okay, he is trying to update the stock value. Let's consider this particular laptop product. However, currently the stock value is 20. This transaction 1 is trying to update the value to 10. Now at the same time transaction 2 wants to read the stock value of that same product. Read stock. What value it will display to transaction 2? It will display 10. Think in real time perspective, is this behavior is correct? No, right? So what transaction 1 is doing here, he is trying to update the value. Does he committed the changes? No, he didn't commit the changes. It means transaction 2 is trying to read uncommitted data. What if in future or after some time transaction 1 will roll back the change? If you will roll back the change, it will be updated to the 20. But what this transaction 2 is getting the value? It is 10. It means the data is not consistency between these two transactions. If you will use isolation label read uncommitted, what transaction 1 is doing, that uncommitted value will also read by transaction 2, which will lead the data inconsistency issue in their application. Okay, so this is the simple use case to understand read uncommitted. If there are two transactions, one transaction is doing some update on the value, transaction 2 should not get the uncommitted data. That is what the read uncommitted. Okay, don't worry, I'll show you in the code and I'll also show you the console output by using this read uncommitted. If still you are not clear with this particular use case, let me give you one fun example. Okay, then you can relate what I was trying to convince. Now imagine, okay, let me go here. Now imagine you and your girlfriend want to watch some movie in this coming weekend. Okay, you both wants to watch some movies and think there are total 2 ticket is available in theater. Okay, total 2 movie ticket is available in the theater. Now there is a transaction 1, some guy, okay, Rahul, he is trying to book the ticket. Now there is another transaction, transaction 2 let it be, that is you and your girlfriend. Okay, now what Rahul is doing, Rahul is trying to book the ticket. He also need 2 tickets, so he is trying to book the 2 ticket. Okay, but he didn't pay, he didn't commit the changes, he didn't confirm the ticket booking. At the same time, when you and your girlfriend was searching for the ticket, you guys are getting 0. Okay, because he already took the 2 ticket, but it is showing you 0, there is no ticket available. Now this Rahul, worst fellow, what he will do, after some time he got some different plan, he will roll back. Hey, I don't need ticket, I will just simply log out from my system. Now since you guys, when you search, you found the ticket availability is 0. Now after some time this guy released, but still it is 0 for you. In this case, what this transaction 2, you and your girlfriend get the result, since Rahul was trying to book the ticket but he didn't commit it or he didn't confirm the booking, still it is showing you, hey, there is no ticket for you. After some time he roll back, ticket is available, but you already logged out. In that case, definitely there will be a big fight in your home in weekend, right? So what you understand here, transaction 1 did the changes but he didn't commit the changes. At the same time, transaction 2 was trying to read the same product, so it is showing uncommitted data to transaction 2. That is what the data inconsistency. So you can consider the movie ticket scenario, or you can consider update the product and read the stock or read the product stock at the same time. Okay, so we'll go with this particular example. You can try with this particular movie theater example. If you are feeling happy with this, go with it. Okay, both the way I'm trying to convince the isolation read uncommitted behavior. Fine. So let's try to reproduce this use case in action. Let's go to our IntelliJ IDEA. Let's create the project and do the magic. So let's create two method. Okay, one will update the stock, one will check the stock. So already I created this service. There is no rocket science. So if you see, this is the update stock method. We'll just get the existing product from the DV and update the stock value and save the product object to the DV. Okay, and then we have check stock, who is nothing, who will fetch the product object from the DV and return the available stock quantity. That is what I have created two different method to just simulate two different transactions. Okay, so let's consider this is a transaction A who will update the stock, and this is transaction B who will just check or fetch the stock. Okay, so if you see the code, what I am doing, after transaction A update the value, I was trying to sleep for some second to simulate transaction B to get a chance to execute. Okay, then that's it. Now let's create two different thread as a two different transaction. One will call this update stock and another one will call the check stock. Okay, then we'll see in read committed how it behaves. So for that, first you need to define transactional. What is the isolation we are going to discuss now? Isolation read uncommitted. Pasted here. Okay, we are trying to see the behavior in the read uncommitted. So whether we want to validate whether this check stock method is reading the committed data or uncommitted data, because that is what we have defined here. Now let's see the output, then we'll understand what we just discussed in a theory. Now let me create another package here. Now here I'll just add a class read uncommitted demo. I'll show you what I'm doing here. So see the method name test read uncommitted. I have created two different transactions by creating two different thread. This is a transaction A, which is nothing your thread 1. This is a transaction B, which is nothing your thread 2. Now what this guy is doing? This transaction 1 is trying to update the stock. So let's validate what is the value in DV now. It is 10, right? So let's update it to 20. Or let's make it 50, okay? So the stock value for laptop is 50 now. So what this guy is doing? This guy is trying to update the stock value to 5. Okay, but he didn't commit it. If you see here, he didn't commit it. After that, we just stop that thread for, or we just ask that thread to sleep for 5 seconds. At the same time, we initiate another thread which is nothing but transaction B. He will wait for 2 seconds and then he will just fetch the product. Okay, so he just need to wait a moment to ensure thread A start and hold the transaction. Okay, this is a simple use case, guys. Okay, so to just understand isolation, we need two different transactions who can run concurrently. So that is the reason I have created two different thread. Now let me define a controller and we'll access this and we'll see the result. So just go to the controller class. I'll just define here only some test isolation. So read uncommitted demo, right? Just use this, just inject it. Okay, so I'll just use read uncommitted demo dot test read uncommitted. Let me hard code it one. Okay, I mean I just want to check for the laptop. I don't want to pass the value from here. Now why this is there is error, just throw the handle the exception. Okay, I'll just throw it for now. Just define get mapping and just define isolation. Now once I trigger, okay, return something, return. So once I trigger this particular endpoint, it will call this method, who will create two different transactions. One transaction will update the stock, another transaction will check the stock, and we have just play with some time to sleep the transaction 1 for some time, so that this will get chance. After this, we'll ask this guy to sleep for some time, so that transaction A will get some chance to execute. Okay, that is how we just play with the time. All good. Now before that, now what we understand here, what is the current default isolation set to my DV? It is set to repeatable read, but we are trying to demonstrate read uncommitted, right? So I need to update it to the read uncommitted. I need to set the transaction isolation label to read uncommitted. So this is the command. You can override the transaction isolation label in your DV. Okay, now I just update it. Now if I'll check the, now what is the value it is showing to me? Read uncommitted. We are good now. Let me restart the application. So application started here. Now just clear it. Go to the browser. Open Swagger. Try this particular endpoint. We'll validate through the console output. Okay, just execute it. Now read the output carefully. Okay, so see here. First transaction A update the stock to 5, which was 50. Transaction A was trying to update it to the 5. Now at the same time, transaction B read the stock as a 5. Okay, now tell me here, when transaction B was trying to read the value, does transaction A committed the changes? No, right? He just update, then we ask him to sleep for 5 seconds. Then immediately when transaction B get the chance and he read the value, he is getting 5. It means earlier it was 50. The value was updated by the transaction A, which is not committed, but transaction B was still able to read the uncommitted data. Can you see here? Same movie ticket scenario you can consider. There are 50 tickets available in the theater. Transaction A is nothing. Rahul was trying to book 45 ticket. Sorry, he was trying, yeah, correct. He was trying to book 45 ticket. Now, at the same time, when transaction B, you or your family want to check the ticket status, you guys are getting only 5. Even though Rahul didn't commit those 45 ticket. Correct? This is something called uncommitted read or dirty read. Okay, if you see here, stock read by transaction B is this. After that, this guy committed. After transaction B get the value, this guy committed it to the DV. Now if you check in the DV, what is the value of product? The value is updated now. Now let me update it to 50 again. What we'll do? We'll intentionally ask transaction A to roll back after read by transaction 2 or transaction B. Okay, so let's simulate that rollback scenario. Just go to your product service. Now here, after it sleep, you just simply roll back it. So just simply use transaction aspect support or something. Yeah, transaction aspect support dot current transaction status dot rollback. Set rollback only. Okay, currently we are explicitly doing the rollback. Fine. So I'll just add a statement here. Transaction A rolling back the update or something like that. Just comment this for now. Fine. So let's restart the server. Then just clear this. Go to the Swagger. Trigger the request again. Now see the magic. What happened? Transaction A is trying to update the stock value to 5. Fine. Then at the same time, when transaction B was trying to read the value, he is reading the uncommitted changes. That is 5. Transaction B is 5. Now after some time, this transaction A rolling back the update. Same like Rahul. Okay. Now what is there in DV? If you validate in the DV, it is 50. But what this guy is saying, this transaction B 5, because at the same time both transaction was playing with the same data. However, transaction B was only reading the uncommitted data, even though that 50 stock is back to the inventory store, but still it was 5 for transaction B at the time when he was reading, or at the time when he was fetching the stock value. Okay, so this is called dirty read or uncommitted read. Now what I want to do, I don't want to read the uncommitted data, I want to read only the committed data. For example, if you will understand the same use case, here we have two transactions, transaction 1 and transaction 2, right? Transaction 1, let's say the value was 20. Transaction 1, I will create another transaction here. Transaction 1 is trying to update it to the 10. Transaction 2 at the same time is trying to read it. So rather than showing the uncommitted value to transaction 2, he should read the committed data, because transaction 1 is trying to update it to the 10, but he didn't commit it. Okay, he didn't commit. Until unless transaction 1 commit the changes, transaction 2 should get the committed data only, which is nothing 20. Okay, so how you can achieve that? That is what our next isolation label, to read the or to avoid the dirty read and only read the committed data. Okay, so what I'll do, let's go to the isolation. We are done with this read uncommitted. Okay, we understand the problem using read on uncommitted, which is nothing, it allow dirty reads which create the data inconsistency throughout my application during the transaction. Okay, to avoid that, what we can use, we can use the read committed. This is the second isolation we are going to discuss now. Fine. So what I will do for that, I'll just revert this rollback changes. Fine, I'll just revert this two line, or I'll just comment it. Now this update stock, I want it to be run on the read committed isolation label, so that I can only read the committed value. Read committed. Okay, so I will just use the same code. Let's use the same. Yeah, so better I'll change it to some different name, or you can duplicate it. Better let me duplicate it. Okay, same code only, I'm just trying to add different demo, so that it will be clean for you to understand. Same changes, there is no other things added here. Fine, so let me inject this read committed demo in my controller, then we'll understand the flow. So you can use the same endpoint. I'll just comment this read committed demo. Okay, dot test read committed, pass the id as 1. Fine, see here there is no rocket science. Again I am creating two different transaction, transaction 1 and transaction 2. One will update the stock, one will fetch the stock. So currently let me update the stock value. What is the value now? 50, right? Let it be. Now let me give you some advanced hints about the console output, so that you can relate. Okay, read committed will not allow any dirty read or any uncommitted read. So here, what is the value? Stock price 50 for laptop, right? Because that is what the id we are giving here in the controller class. Fine, So just go to the read on commit, not this one, committed demo. What this guy will do, this guy will try to update that value. Earlier it was 50, this guy will try to update it to the 5. Okay, now at the same time, when transaction B will try to read the value, what should the value display to transaction B? Since we are asking both the transaction to use only read committed data, here transaction B should read the value as a 50, because there is no guarantee, right? What is the thread A is updating the value, he will commit it. What if he roll back the changes, right? So I don't want to go into that mess. Rather give me the clean value which was last committed earlier. Give me only the committed value. I don't want to see any uncommitted value, or I don't want to deal with any dirty value. Okay, so here you will get the output as a 50. Let's run the code and we'll validate the result. But before that, go and check in your DB what is the current transaction isolation label, that is set to read uncommitted, right? Just override it to read committed. This is not mandatory step what I am doing here, but sometimes since I am using the MySQL, it will behave differently based on the engine what you are using. So if you see here, the product table I am using InnoDB. Sometimes it will force you to use my ISAMDB for some different isolation behavior. Okay, again, no need to go in details about it. If you have PostgreSQL, you can happily play with all different type of isolation. But if you have MySQL, for safer side, just override the isolation label what you want to test. It's just 1 second task, right? Okay, now if I will search, not this one, if I will search the isolation label, it's now read committed. So just restart the server. So it started. Just clear it. Go to the Swagger. Just trigger the request. Go and check the output in your console now. Okay. Can you see here? From where it started here, right? What is the earlier price of the stock where the product ID is 1? It is 50. Transaction A is trying to update the stock value to what? 5. He is trying to update, but he didn't commit it. At the same time, we allow transaction B to get the task done. I mean, we just ask transaction A to sleep for 5 seconds. So same time, transaction B get a chance. He was trying to read the stock value. He is getting 50. That is correct, right? This is not uncommitted data. This is the last committed value, because there is no guarantee whether transaction 1 will really update it or he will roll back it. So I don't want to go with that mess. Better give me the last committed value. Fine. You can relate the same use case to the movie theater example as well. Okay. Now transaction B read 50. Later he committed the update. Now if you check in the DB, what is the value? 5. Let it be. Because I was not sure whether transaction A will update the value or he will roll back. The time when I was fetching the things, it should give me the last committed value. So I only want to read committed data. This way you can avoid dirty read. Okay. So if you go here isolation, we understand using read uncommitted allow us to read dirty content or uncommitted data. However, you can avoid that or eliminate that using read committed. But again, there is a problem in read committed. Now, what happened? Let me tell you. So, let's say, let me open the new page. Now, imagine again same product table where the initial value is 50, the stock value for laptop, that is the ID 1, right? Now, this is transaction 1, this is transaction 2, transaction 1 and 2. Now, what transaction 1 does, he update the stock value. Update the stock value to 10. But transaction 2, when I will use the read committed, when it will read, it will fetch the value as a, what is that, 50, because that is the last committed value. We are not sure whether this will getting update or it will simply roll back in some time. We are not sure about this behavior. So when transaction 2 read the value, you will get the last committed value. Now imagine this value is update in the DB, but again still this is not committed yet. Okay, this is not committed yet. Now again this guy transaction 2 will try to read the value, he will not get 50, rather he will get the value 10. So what I want here, I want to maintain the consistency before transaction update and after transaction update. How many times I will fetch the value, I need the consistent result. I don't want any inconsistency while processing or while reading when the transaction is active. Okay, so in that case, to avoid this kind of issue, you can use repeatable read isolation label. Okay, repeatable read. Okay, what this repeatable read isolation label does, it ensures that if a transaction reads the same data multiple times, it will see the same data throughout the transaction, even if other transaction modify the data. This way it will prevent the dirty read and non-repeatable read. But again, it does not what I can say, it does not prevent the phantom read. I will come in a moment, I will explain in a moment about the phantom read. Okay, this way you will avoid the dirty reads, which is nothing your uncommitted read, and non-repeatable read also you can avoid if you are using repeatable read isolation label, because I want the consistency value. Okay, now let's understand the same use case in action. Just go to the code. Now what this guy is doing, transaction 1 update the stock, that is correct, that is the expected, because if you understand here, transaction 1 update the stock. However, this transaction 2 is trying to read multiple times. Okay, so let's create or let's read multiple times in check stock. Better I'll create another method called fetch stock, who will read the stock multiple times. While you'll read multiple times, you should get the consistent result. So what I'm doing here, this is the product 1 which I am fetching from the DV. So I added the meaningful messages, transaction B first read and the quantity what is the available. Then we wait for 3 seconds, we simulate the delay to allow transaction A to update the stock. That is what I explained here, right? Before and after update the value should be same. I want 50 here. Before update and after update also I should get the same result. Okay, so that is what I am doing here. Fetch the first product, then wait for 3 seconds, let transaction A to execute, then immediately I have the second time I am fetching the same product and I am printing what is the value I am getting. Okay, so let's say let's change some different number. Okay, let's keep it 40. Now if we'll check the product, what is the value? 40, right? Now here what we are expecting here, this guy, this update stock, this particular method will update the value to 5. However, the initial stock is 40, right? So in the fetch stock, at the first read, I want the value to be display constant 40. Then in second read, also I want to see the value as a 40. I don't care if any transaction is doing any modification in between. Since my transaction is active, how many times I will fetch the result, I will get the constant output. Okay, that is what all about repeatable read. So I will also change the isolation label to repeatable read here. All good. Now again I will create another demo class to simulate the repeatable read. Let me duplicate this. Okay, just go here and paste it. Same thing here. Transaction A will update the things. Transaction B will read the value. Okay. While read, we have mentioned to read it twice. This will be before any update by transaction 1. This will be after update by transaction 1. Transaction 1 means transaction A. Okay. Now let's run it and we'll validate. Before that, just use this class and inject it in your controller class. Just comment it and then use repeatable read demo dot demonstrate repeatable read, give the product id 1. Okay, once again just cross validate. What is the product details? This particular laptop, the quantity is 40. Now what is the current isolation label set in my dv? It is read committed. What I want to keep it read repeatable, right? So let me change it. Just let me copy the proper name. Okay, repeatable. What is the error? Repeatable. Okay, this should be repeatable read, not read repeatable. Fine. Now if we'll check the isolation label set in your dv is repeatable read. Well and good. Now let's restart the server. So it started. Just clear this. Now go to the Swagger and trigger the request. Now if we'll check the output. Okay, what is the first? Where it went? Yeah. So first transaction B get a chance to execute. That is nothing thread 2. So he read the value first 40. That is what they are in our dv. Then transaction A get a chance and you update the value to 5. Then after update, see this. This is before update and this is after update. What is the value? Is this constant or not? Transaction B first read is 40. Transaction B second read is also 40. And in between that, this guy is updating the value. So transaction B no need to care about it. I want the constant before and after update the things. That is what I am getting here. This way you can avoid the repeatable read. Okay, that is, see what things you can avoid. For that solution, the isolation label name is there. So I don't think it will complex for you to remember what repeatable read does. It will avoid repeatable read. That is the first statement. Now while explaining this, you should understand, okay, what do you mean by repeatable read? Okay, that is how you can understand the thing. So fine, the first before update the value was 40. Let this guy update, I don't care about it. After update, when I see the value, it is 40. And if you, I didn't walk through this statement in this isolation example because already I explained in the propagation, right? How it creates the new transaction, how it reuse the transaction. So you can validate that. We are good till this point, right? We are done with the repeatable read. Now let's move to the last one, that is serializable. This is very interesting properties as part of isolation. So if you are using serializable isolation label, then it ensures that transactions are executed in a manner equivalent to running them sequentially one after another, even if they are executed concurrently. Okay, now for example, now here we have two transactions, right? One is doing modification and other one is getting issue. Now what this serializable does, this transaction, this isolation, what it does, you have transaction 1, you have transaction 2. Okay, this guy is trying to update, this guy is trying to read. Now what it does, once transaction 1 started, at the same time if you will start the transaction 2, even though both are executing concurrently, it will apply the lock. Serializable isolation will apply the lock. First let this guy to complete the task, then only it will give chance to execute your transaction 2. There will be no concurrent execution. It will be kind of synchronous execution one after another. One transaction complete their job, then only the serializable will release the log to transaction 2 to execute the task. Okay, both can run parallelly. In this way, the movie theater seat booking ticket issue will be completely resolved. Okay, I don't know, I'm just giving the hints. You need to find out and answer me in real time while booking the flight ticket or while booking the movie ticket, which isolation label is the appropriate solution for it. Okay, what I should use in real time. So you need to answer me in a comment. Fine, let's understand how this serializable isolation will execute one after another, whether it is really maintain the synchronous, or if you run in concurrent way it will break. Let's validate that. Okay, so just go here, and what I will do, I will just go to the product service. I will just change it to serializable. Check stock. Now nothing to do. Let it be. This we are not going to use now. I mean, this is just to do the repeatable read validation. So what we can do? Let me duplicate this. Okay. Then we will just add another one for serializable demo. So I have just created different demo class, but if you check the code, there is no change in this particular class. At the end, our ultimate goal to spin up two thread to just simulate two transaction use case. So that is what I am doing in all these four class, but I just segregate it for better visibility. Fine. So nothing, again transaction A or transaction 1 will update the stock. This guy will read the stock. That's it. Okay, so I am forcefully trying to sleep so that we can validate. Okay, one thread first get the chance. Let's see that. Okay, so nothing to do. Let me copy this class name. Just go to your controller class. I need to inject it. All good. Now just call the method. Just comment this. So let's do one thing. Let me disable this log. Okay, otherwise we need to read so many logs. So better let me comment this. So all good. Let me restart the app. Here what we should observe. First let me change some other value. Let's keep it 20. Okay, so here the expectation is very simple. I want, even though we have started two transactions concurrently, both can't run parallelly. Rather, serializable will force those transactions to run one by one. Let's see the order. Okay, but before that, let me check what is the isolation. We have repeatable read, right? We need to change it to the serializable. Now if we'll check the isolation, what is the value? It is serializable. All good to go. Now just go to the Swagger, just execute the request. So if you'll go and check the console output, yeah, see the magic. Transaction A execute first. It stock the update. Okay, then it print the messages. After this transaction A execute, it started executing the transaction B. See the order. A first, then B. Can you see here? Now there is no data inconsistency issue. Transaction A execute first, it update the stock and commit the value. Hence, at the same time when the transaction B will try to fetch the record, stock quantity is reflecting correctly. Can you see here? This way, if you are using serializable, it will always guarantee there will be no dirty read, no phantom read, okay, no repeatable read. But since the flow is going to be synchronous, it will lead the performance issue. So if you want to play with huge data, it's not recommended to play with the serializable, because it will apply the locking mechanism which will slow down your performance. But again, we cannot say it's not recommended. It is highly recommended in real time project. Okay, so you need to figure out when to use it. So I already give you the clue when to use each and every isolation label. So to just brush up the things what we have discussed, let me summarize all the isolation label. So if you see this, I cannot zoom this because the image is not clear. Anyway, it's fine, right? It's visible, I believe. Now, read uncommitted. What it avoids? Nothing. We found the dirty read uncommitted data which we discussed. Okay. Now read committed. What it avoids? It avoids dirty reads. Okay. See only committed data. That is what also we validate. Now repeatable read. What it avoid? It avoid dirty reads, non-repeatable reads. Ensure consistent read in one transaction. We try to read multiple times, but we get the correct value. Between that, other transaction when they are trying to update the value, still it don't impact anything to us. Okay. Now the last one which we just discussed, that is serializable. What it avoid? It avoid everything. It avoid dirty read, non-repeatable read, and phantom read, fully isolated transactions. So in real time, it's recommended to use read committed, repeatable read, and serializable. Okay. So I believe we are under same page. If yes, then given a scenario, you should be in a state to figure out what isolation label I need to use in this case, or what is the propagation label I need to use. You should be in a state to figure it out. So try playing with different isolation and propagation label, and do let me know in a comment section if you have any doubts.
That's all about this particular video, guys. Thanks for watching this video. Meet you soon with a new concept.